So in this video, I'm going to do a demonstration of the empirical formula lab with magnesium and hydrochloric acid so that you can see the lab and take notes, record data, and do the calculations. First, I'll start by talking about the lab handout. So this, let's see. So in this lab, we're going to figure out the empirical formula of a compound. A little bit of background: an empirical formula is the simplest ratio of the atoms in a compound. And the ratios hold true for moles as well, which means we can't count atoms, but we can count moles. So for example, water is made up of 2 atoms of hydrogen and 1 atom of oxygen. So if we want to talk about the molar ratios of the elements in water, then we would say that for every 2 moles of hydrogen, we would have 1 mole of oxygen in water. If we know the molar amounts of each element, then we can use that to figure out the empirical formula of a compound, which is what we're going to try to do. Well, here's an outline of the reaction that we're doing. We're going to take solid magnesium, and it's a metal. And to that, we're going to add hydrochloric acid, aqueous hydrochloric acid, and it's going to do a single replacement reaction. So the magnesium is going to come in, it's going to kick out hydrogen, and that's going to give us a compound of magnesium plus chloride. And we know how to predict the formula for that because we learned that when we did formula writing, except the idea here is that we're going to figure out experimentally what that formula is. And hopefully it will agree with what we know. It's also going to produce hydrogen gas, so it's going to bubble. It's also going to get really hot. So a couple questions to think about as we do the lab. How are we going to determine the mass of the chlorine? We're going to weigh the magnesium on a scale, but how are we going to figure out the mass of the chlorine? And why can we ignore the mass of the hydrogen gas? So hydrogen is one of our products, but we don't have to think about that one. I'll let you think about why. We're going to use the masses of magnesium and the mass of chlorine to determine the moles of both to get the mole ratio, and that will help us figure out the empirical formula for magnesium chloride. All right, the procedure is in your lab handout. You want to follow along as I do it. There's a data table to record the data as we go. And then after you collect the data, there are calculations, and it should walk you through the calculations and let me know if you have any questions. And there's some, and then there's some questions at the end also. All right, so here we are, stuff that we have and we'll need. We have magnesium metal, and it's, you know, typical magnesium we've used for a few things this year. I have already sanded off the magnesium, so to make sure it doesn't have any rust or oxidation, it's pretty clean, so it's just pure magnesium. And we have an evaporating dish, which we're going to use at the end to evaporate off the water. So because we're going to have our solid left in the evaporating dish, we're going to get the mass of the evaporating dish. Let me move this so you can see it. There we go. So the mass of the evaporating dish is 54.37 grams. Okay, we're not going to need that till later, so I'm going to set that over here. And then I'm going to record the mass of the magnesium, which is 0.41 grams of the starting magnesium. All right, so then I'm gonna take my magnesium and I'm gonna put it in the beaker. Let me move this so you can see it. I'm gonna put the magnesium in the beaker. I want it to lay flat, so I'm gonna coil up my magnesium so that it lays flat in the beaker. I want to add as little acid. Let's see if I don't know if that's going to work. I'll just set it in there. Okay, good enough. So the magnesium is in the beaker. I'm going to set it here. And to that, I'm going to add hydrochloric acid. I don't want to add any extra acid, so I'm going to add the acid fairly slowly. It's going to bubble. It's going to get really hot. I'm going to add it slowly, and I want to stop adding as soon as all the magnesium has reacted. So I'm going to go pretty slow here. Turn the camera on so you can see that. Let's see. There we go. That's better. And this is 3 molar hydrochloric acid. It's fairly concentrated, not the most concentrated, but it's quite concentrated. So you'll see what happens. It makes hydrogen gas. It steams a lot. It's pretty nasty. It smells pretty bad. So I'm gonna swirl this. It's definitely warm. Let that react. I want to see if all the magnesium has reacted. I'll let it go for a few minutes here. I'll know when the magnesium has all reacted because it will all, I won't be able to see any more magnesium. So it's getting there. I think there's still some magnesium left. I'm gonna let it stop bubbling. Let it finish reacting what it's, make sure all the acid has reacted, and then I'll see if I need any more. Still going. It's very, very hot. Pretty warm. Yeah, it's still bubbling. See it? It's still going. Yeah. I'm gonna wait till it stops bubbling, and then I'll see if I need any more acid. All right. Still bubbling. And I don't know if you can see it because it's around the edge. It still has a little bit of magnesium in there. I can't touch it, but you can still see it. You can see it here. Yeah, see that magnesium is still there. So I'm going to add a little bit more acid. Hopefully it's almost done. Yep, it's definitely not all done because it's still bubbling. Let that go. See that magnesium sticks to the side there. It's still not quite all reacted. It's getting there. Don't want to go too fast because I don't want to add too much acid. When I'm done, it should look pretty clear and colorless when I'm finished. The bubbles should be gone and the magnesium should be gone. Don't think we're quite there yet. There's still magnesium left. All right. Impatient. Just gonna add a little bit more acid. And then I will wait. Okay, little tiny bits left. I think there's enough acid in there for all of them to react. Let's see. It's going slower and slower, so. All right, I think it's just a tiny bit left. I'll do one more bit. Yeah, the bubbles have nearly stopped, almost there. All right. Come on. I think it's done. Every time there's just a tiny bit left. Okay, I think. All right, I think that's it. So we have no more magnesium left. It just looks like water. It is primarily magnesium chloride, but we know that magnesium chloride is soluble in water. So what we want to do now is get rid of the water and record the mass of the magnesium chloride that we have left. So to do that, I have a hot plate here, and I don't want to do it in a beaker because I'm worried it's going to get too hot and the beaker might break. So I'm going to evaporate it in what's called an evaporating dish, which is porcelain, which is made for high temperatures. I'm just going to set this on the hot plate. I'm going to turn the hot plate on so that it starts getting hot. And while we'll get it started evaporating. I'm going to transfer all of it to the dish. So I could afford it. All right, so all of my aqueous magnesium chloride is now in my evaporating dish. If you can see that, it looks like water. And I'm going to put that on the hot plate. It's going to get really hot, so I will use tongs to remove it. And I turned the hot plate on a little bit earlier to try to make it a little bit quicker. It should start to boil shortly. And then I might just pause the video if I have to wait a while. Just watching water boil is not so exciting. So I'll just leave that there for a second. So at least we can see it getting started, boiling and evaporating away. So I'll turn it up a little bit. I don't want it to be so hot that it might crack. All right, I'm going to pause the video and then just turn it back on when it's doing something interesting. Okay, so I've turned the video back on. You can see it starting to boil here. This took, I don't know, maybe 5 minutes or so. The water's boiling. And what we want is for all of the water to evaporate and boil off so that we're left with just solid magnesium chloride salt. I'm going to pause again just because it'll just be easier to watch. Okay, we're still, it's been about 10 minutes or so. We're still boiling off the water. It's definitely gotten, it's like it looks a little thick in there. It's definitely less water than before. You can start to see the solid magnesium chloride form around the edges a little bit. And we've had a little bit of splattering, not too much splattering, a little bit of splattering there. And I'll just let it keep going. All right, it's been about 5-7 minutes. We are still evaporating. It's still boiling. The liquid is starting to look a little bit yellow, but the solid is definitely white. You can see it start to form around the edges where it's getting dry. And I don't want to heat it too hot. I'm worried it'll crack. So we're just gonna keep going. All right, so it is mostly all evaporated. There's still little bits of water left. So I'm going to keep that on there for a few more minutes. You can see a lot of white formed around the edges. That's the magnesium chloride. And the water is still, there's still a little bit of water boiling there. It's hard to get all the water out. See, as it dries out, it looks white and kind of dry around the edges. close. Let's see it. Okay, that last bit of water is dry, is evaporating there. Okay, so all the water evaporated pretty well. Let's see if I can see it. It's hard with the light shining on there. Looks pretty dry. I was starting to worry about it. All right, you can see that it looks white and crystalline, which is what we want. It's cooled off a little bit. I want to put it on the stove, or sorry, put it on the balance and get the mass. This will be the mass of the evaporating dish with the magnesium chloride. Oh, let's see if you can see that. So it's 56.11. And then I really want to make sure that it's all the way dry. So I'm going to put it back on the hot plate just for a few minutes. I left the hot plate on, so it's still hot. I really don't want to, I want to make sure that it doesn't crack or break. So I'm not going to leave it on there too long. I just want to ensure that all the water is gone. And when we weigh it again, it should have the same mass or close to the same mass as before. If the mass drops a lot, it will tell us that we're still getting rid of water and we might want to heat it a third time. I don't really think that'll be necessary though. So it's pretty dry. There doesn't seem to be any water left. I'll just let it go for a minute and then I'll take it off again and cool it again. Okay, so I took it off the heat a second time. I'm going to shut that heat off now. And the mass now is 56.09. And that's, let's see, show that 56.09. And that is after the second heating. And because the mass didn't drop very much, I'm not going to heat it a third time. You can sort of see what it looks like in there. It's pretty dried out. It's good. All right. And that is all the data. And let me know if you have any questions.